Problem number 8 on the active physics assignment, chapter 1, section 4 in the Physics to Go, asks about some acceleration, average speed, distance, comparative problems. Question number 8 says that at an international auto race, a race car leaves the pit after a refueling stop and accelerates uniformly to a speed of 75 meters per second in 9 seconds to rejoin the race. I've gone through and I've done some problem solving for 8A, B, and C, and you can use that then to model how you approach question number 8, letter D, and then also question number 9. I'm going to show you my solution. So starting out with 8A, you are given some information about a car leaving the pit stop. Initially, even though they don't say car starts at 0, we can assume that if he was in the pits, he was stopped, so his initial, or VI, velocity is 0 meters per second. Speeds up until he reaches 75 meters per second, and the time frame for that is 9 seconds. They are asking you to calculate A. A is the change in velocity, or VF minus VI, divided by change in time. So 75 minus 0 divided by 9 is going to give you an average acceleration of 8.3 meters per second squared. 8B asks about an average velocity. It wouldn't be fair to compute some kind of a distance based on one particular value, either the ending value or some kind of a starting value. So if you look at VI and VF, the average is going to be the addition divided by 2 of that, which would give you 37.5 meters per second. Then to calculate how far that car traveled during that time frame, we take the average velocity of 37.5 meters per second multiplied by the time that it was accelerating, 9 seconds. Distance is going to be, just like distance is speed times time, distance is also velocity times time. Here we're using the average velocity. So 37.5 meters per second times 9 seconds is going to give you a distance of 337.5 meters. Be aware that for problem number 8D, you're just going to be changing the time frame, but you're still going to be using the same kind of pattern of looking at an acceleration and looking at an average velocity. A quick heads up just for problem number 9. Acceleration for problem 9 has to do with a girl running between bases, playing softball, and sliding. Since sliding is going to be slowing down, there's going to be a negative value for the acceleration. You should always get positive values for time, so as you are computing through, check your signs, make sure that as you're dividing or moving things from one side to the other, that you're keeping your signs consistent so that you end up with correct information.